here, Professor Idris Karnan with the PS Students Mechanics. We are dealing today another example here. Okay, let's come towards its statement. A particle is projected vertically upward. It means particle is vertically upward. It means particle is moving like this from down to up, vertically upward. You got the point? Particle is projected vertically upward at t is equal to 0, velocity u. It means its initial time and its initial velocity. Means it is projected with initial velocity u. Okay. Passes a point P at t is equal, passes a point P at a height h. It passes through the point P. That P point is present at a height h. Okay. And it passes through the P at t is equal to t1 and t is equal to t2. It means it passes through the P at t is equal to t1 and then it passes through the P at t is equal to t2. What does it mean? That it passes through the point P for the 2 times. It means once a time when it is moving upward and the second time is when it is moving downward. It means at t is equal to t1, it is passing through the point P when it is moving upward and t is equal to t2 when it is coming downward at t is equal to t2. What you have to show? You have to show this thing, that their sum equal to 2u over g and their product equal to 2h over g. Okay, let's come here towards, okay, this, let's see here, this is your particle, it is moving up and it is moving upward. Here is a point P, which is present at a height h. It's okay, your particle is moving upward and here at t is equal to 0. And keep in mind its initial velocity when it was projected, its initial velocity was u. Another thing, when it was moving upward, it means is at that time t was t1, and when it was coming down, when it was like this coming down, it was at t is equal to t2. It passes through the P at T1. It passes through the point P at T is equal to T2. I think you got a point that at T is equal to T1, it is moving upward. At T is equal to T2, it is coming backward. But at the same T1 and T2, both are the time when the particle is present at point P. And P is present at height h. Initially, it is projected with velocity u at t is equal to 0. What we have to show this thing, that this t1 and t2 is sum is 2u over g and its product is 2h over g. What is u? You know its initial velocity. What is h? It's the height of the point P from the earth, from the ground. So you got everything here. Okay, let's come here. We write something about that. Suppose a particle is projected. Suppose a particle is projected vertically upward with velocity u. With velocity u from point O, this is the point O, this is O, from point O. And it reaches a point P and it reaches point P after time t. Okay, you know, since this is second equation of motion, x equal to ut plus half at square. Now just see here, x is a distance. You know, for reaching the point P, how much distance is covering? It's h. So x will be h here, is ut plus half, because the particle is moving from down to above. Vertically upward it is moving. So a will be minus g here. Keep in mind, a will be minus g here. A will be minus g here into t square. Just write a reason that a is equal to minus g, because particle is moving upward. So what I got? I got h equal to ut minus half gt square. Multiply by 2. Multiply by 2. If I multiply whole equation by 2, I'll be getting this thing 2h equal, here it will be 2ut minus, here 2 will be cancelled, it will be gt square. I want to make it quadratic in t. It means I will bring these two terms here, it will become plus here, it's a 2ut, it will become minus here, and plus 2h equals 0. Now what is this? This is quadratic in t. The coefficient of t square will be a, the coefficient of t will be b, and this is c. This is quadratic in t. So I can say here, this is quadratic in t. And you know, whenever you have a quadratic equation, it has a two roots. So it means if this is quadratic in t, so I can let it has a two roots. Let's say it's a t1 and t2. Let its roots are t1 and t2. Okay. What is a here? It is g. What is b here? The coefficient of t is a minus 2u. What is c here? It is 2h. You know the formula? That if you have a two roots t1 and t2, t1 plus t2, you already studied these things. That sum of roots has a formula, minus b over a. Sum of roots formula, minus b over a. Minus will be as it is. What is b? It's minus 2 over a. It is g. Minus minus will be plus. It will be 2u over g. So you got a sum of roots. Now you want a product of roots. Okay, what do you have to do? It means t1 into t2. And what is the product of roots? It's a c over a. And what is c? It's 2h over g. So the both things that I want to prove, I got a proof. Sum of, I'm again revising this thing, this is a sum of roots minus b over a. Product of roots, c over a. And I put the b, a. C over a, I put the c and a. I got a proof what I want to prove. This. That sum t1 plus 2u over g, t1 into t is equal to 2h over g. Again, I'm revising this thing for you. The t1 is the time when particle is moving from point P. T2 is time, it's again from moving from point P. But T1 is a time when it is moving upward. T2 is a time when we have no concern with the value of T1 and T2. We don't want to find out the value of T1 and T2. Why? Because we don't need it. We just need its sum, we need its product. We don't want a value of T1 and T2 here. Just we want a sum, we want a product. And I got it. So it was an example here. Now we have another example here. Okay, let's come here towards another example. Find the distance traveled. Find the distance traveled and velocity. Find the distance traveled and velocity attained by the particle moving in straight line at time t. At time t. If it starts from rest, if it starts from rest at t is equal to 0 and is subject to and is subject to an acceleration a equal to t square plus sin t plus e power t. Okay, let's come towards its solution. Okay, just write here a equal to t square plus sin t plus e power t. Keep in mind, you want to find out two things. You want to reach towards distance, you want to find out a velocity. And all other things, these are the initial conditions. It starts from rest. From rest means initial velocity will be 0. Okay, t is equal to 0 and is subject to an acceleration this a. So these things you have to keep in mind. Okay, you know, in the previous lecture I told you that acceleration is a rate of change of velocity. Just write down here a reason that this a equal to dv over dt. Rate acceleration is the rate of change of velocity. So rather than a, I can write here dv over dt. It's a t square plus sin t plus e power t. If I want to find out v, what I have to do? I have to integrate it, because integration is the reverse process of derivative. If v has a derivative dv over dt, if I integrate this thing with respect to t, I'll be getting v. It means I have to integrate it with respect to t for getting v. Okay, write down here integrating both sides, but with respect to t. Okay, here dv over dt into dt, here t square into dt, here sin t into dt, here e power t into dt. Okay, just see here dv over dt, its integration will be v. T square, you know, its integration will be t cubic over 3 power. T square has an integration t cubic over 3. You know all these things. You are a higher level students. Okay. Sin t, its integration is minus cos t plus e power t has an integration e power t and plus a. I can call it equation number 1. So what I will say here, that this a is a constant of integration. Its value can be found out by using initial condition. And whenever I will find out the value of a, I'll again put a this in equation number 1. I'll be getting b. But I have to find out a because it's the integration constant. Okay, what I will say here. Okay, you can write the vector sign, because it's a velocity and velocity is a vector quantity. So if you place a vector sign, no issue. It's a good thing if you place a vector sign there. Okay. Now what I say here, where this a is constant of integration and its value can be found by using initial conditions. Okay, let's see here. What are the initial conditions? At t is equal to 0, it starts from rest. Starts from rest means that initial velocity is 0. So I say here that at t is equal to 0, velocity will be 0. Okay. I'll put v equal to 0 because initial velocity is 0. T 0, so first term will become 0. Here t 0, it means it will become minus cos 0 plus e power 0, yes, plus capital A. I want to find out capital A here. So let's see here, 0, 0 minus cos 0 will be 1, e power 0 it will be 1 plus A. It's a plus 1 minus 1 will be cancelled. So you are getting capital A equal to 0. So what I'll do? I'll put this A in equation number 1 and I'll be getting V, means velocity. Okay, put A equals 0 in equation 1. So what will happen? Your V will become t cubic over 3 minus cos t plus e power t and plus A0. So finally, I got V equal to t cubic over 3 minus cos t plus e power t. So this is my answer. Means I got a velocity. But now I want to find out a distance. You know already that velocity is a rate of change of displacement. Yes, you know this formula. You can write here v equal to dx over dt. So it means rather than v, I can place here a dx over dt. It's a t cubic over 3 minus cos t plus e to power t. Why I have written this thing? Because I'll integrate this thing and I'll get x from here. So due to this reason, I have written rather than v here, I have written a dx over dt. So I integrate it, and whenever I integrate it with respect to t, I'll get x, and x means I'll be getting a distance, and that will be my final answer. So okay, write down here integrating, and you know also the reason that why I'm integrating with respect to t here, because I want to get a x here. Okay, integrating both sides with respect to t. Okay, this dx over dt with respect to t. 1 by 3 can be taken outside, and it's a t cubic into dt. It's minus, it's cos t into dt plus, and it's e power t into dt. So I'll integrate it. And what will happen whenever I integrate it? It will happen like this. Okay, see here, dx over dt. Its integration will be x 1 by 3. T cubic has an integration t power 4 over 4. You know by the power formula. Minus cos t has an integration sin t plus sin t. This minus will be as it is. And e power t has an integration e power t. I can place here a b, and this is equation 2. Why I'm calling it equation 2? Because here capital B is a constant of integration, and its value can be found by using initial condition. Okay, I can say here where capital B is constant of integration, and its value can be found by using initial conditions. Okay, what are the initial conditions at t is equal to 0? Let's see here. at t is equal to 0, it starts from rest. Initial velocity is 0. But here is no initial velocity. Okay, leave it. At t is equal to 0, how much he covered a distance? Just think, it's a common sense that at t is equal to 0, he covered no distance. It's a common sense that at t is equal to 0, he's not covering any distance. So it means at t is equal to 0, x will be 0. What you will do, you will put x equal to 0, t is equal to 0 here, you will be getting b. Okay, put t equal to 0, x equal to 0, okay, in equation 2. When I'll put here x equal to 0, this will become 0. Here t is 0, so this whole term will become 0 minus it's a sign 0. Okay, and plus e power 0, and it's a plus b. It's a 0, it's a 0, sine 0 is 0, e power 0, 1 plus b. I wanna get b here, it will be minus 1. So I can put this b in equation 2 to get my answer. Okay, let's see here what I have to do. What I will do, I'll put this b in equation 2. Put b equal minus 1 in equation 2. And your equation 2 will become x equal, okay, let's see here. This is t power 4. 4 3 will be 12. It means t power 4 over 12. And it's a minus sine t plus is e power t. What is b? It's minus 1. So you got the answer. You got a x, means you got a distance. I hope so. You got everything. Keep in mind, if you got to understand my lecture, if you like my lecture, please comment something there. And if you found something that there is a problem in, my number is present there in the description. You can ask any question on my website. You can ask any question. If you feel any problem, you can contact me there. You have my WhatsApp number on the description. My WhatsApp number is there. You can contact me. You can ask me. These are the problems. I'll discuss you. Bye bye.